So we're looking at the problem in homework 7, problem D. So the problem is you're in a bookshop which sells n different types of books. You know the price and number of pages of each book. You've decided that the total price of your purchases will be at most X. And what is the maximum number of pages you could buy? That's what we're trying to find. You can buy each book at most once. And so what we're given is n, the number of books, and x, the maximum number that we can spend. And then from there, we're given the prices of each of the books and the pages of each of the books. So each index corresponds to the price and page. So for book 0, the cost is $4 and you can get 5 pages. So let's just look at this input example, for example, and run through that. So the best way to solve this is to use a DP table. So if we think of the DP table as like a function, at index I in the DP table, DP of I, that tells us that at a cost of I dollars, you can get a maximum number of pages of whatever is outputted by that. So we would create the maximum length of our DP table to be the maximum number of dollars that you can spend, plus 1, which is like your 0th index. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me just double check. 2, 4, 6, 8, 10, 11. Yep. And so what we can do here is we can create a DP table where, for example, at price 6, it'll tell us that if you spend $6, this is the maximum number of pages you can spend, like once the DP table is completely filled out. So this is how we're going to do it. I'll run through the examples. So we're going to slowly fill out this DP table by looking at each book one at a time. So I'll just write down book I price and then book I pages. And so book I price, the first one, is going to be 4. And then the number of pages that you can get for $4 is 5. And so what we can find is that at $10, we can spend this full amount of $4 and get 5 pages. At $9, we can do the same thing. At $8, we can do the same thing. $7, we can do the same thing. 6, 5, and then 4. And then 4. And anything below that, we can't really spend more than, we can't spend the $4, right? At $3, you can't spend $4 to get 5 pages. And so when you only have this book, if you're just looking up until the 0th index, you can't spend 3, 2, 1, or $0 to get any pages. And so this is what our DP table would be like if we only knew that. The next part of this, let's look at the next book. So we can spend $8 to get 12 pages. And so here, what we want to do is we want to compare, since you can buy multiple books, you want to look at the maximum of the price that you are looking at right now, that index, minus the price of the book. So as an example, let's say we were looking at this part of the DP table where you're looking at the maximum pages you can get for $10. And so right now we know that for $10 you can get 5 pages. However, what we want to do is we know we were given a new book. So for $8 we can get 12 pages. And so we can see 10 minus 8 is $2. And so we can see 0, 1, 2. So for $2 we can get 0 pages plus the 12 pages that we would get for this book is more than what we were currently found is the maximum that you can get out of $10. And so we would update this to be the new maximum. Then we do the same thing. So 9 minus 8 is 1. That's $0. And 12 is still greater than 5. Then we do the same thing with 8. So for $8, you can get 12 pages. And that's more than the 5 pages we got before. And then anything below that, you can't really spend the $8, so it doesn't matter. Now let's look at the next one. So for $5, we can get a book with 8 pages. This is kind of where it gets interesting. So if we're starting here again, so for $10, you can get 12 pages from what we found before. So now let's try to input this new book. So 10 minus 5 is $5. So 0, 1, 2, 3, 4, 5. So for $5, you can get 5 pages. So if you get 5 pages for $5 and you spend another $5, that means you can get 13 pages total for $10, given these 3 books that we know about. And so we can update this maximum to now be 13. We can do the same thing with 9. So 9 minus 5 is 4. So 0, 1, 2, 3, 4. 5 plus 8 is 13. We could do the same thing here. So for 8, 8 minus 5 is 3. 0, 1, 2, 3. And 0 plus 8 is 8. And so at $8, it makes more sense to just buy this second book than to buy a combination of any other book. So we could just leave that. Then we're looking at $7. And so at $7 minus 5, 0, 1, 2. 2 plus 8, or 0 plus 8 is 8, and that's greater than this 5, so it makes more sense to do that there. 6 minus 5 is 1, so 0, 1. That makes more sense there. And then for $5, 0 plus 8 is 8 as well. 0, 1, 2, 3, 4, 5. Yeah. Okay. And then now we're going to look at the last book. So for $3, you can get one page. And so we can fill this out again. So 10 minus 3 is 7. So 0, 1, 2, 3, 4, 5, 6, 7. And so for $7, you get eight pages. So 8 plus 1 is 9. However, that's still less than 13. So it makes more sense to just buy the third book and the first book. And so we can do the same thing here. So 9 minus 3 is 6. 0, 1, 2, 3, 4, 5, 6. 8 plus 1 is 9, so that doesn't make sense either. Here we have 7. 7 minus 3 is it's 8. Sorry, 8 minus 3 is 5. 0, 1, 2, 3, 4, 5. 5 plus 1 is still not more. We can go here again. So 8, or this is 7. So 7 minus 3 is 4. So 0, 1, 2, 3, 4. 4 plus 1 is 6. That's not greater than this, so you keep that there. Then we'll look again. This is 6. 6 minus 3 is 3. 0, 1, 2, 3. 0 plus 1 is not more than 8. We do the same thing here. 5. So 5 minus 3 is 2. 0, 1, 2. So 1 is still not less than that. And then we can look here at 4. So 4 minus 3 is 1, so 0, 1, still not greater. Now we can look at 3, so 0, 1, 2, 3, 3 minus 3 is 0. And so here you can actually update this. So this is the first time for 3 that you can actually buy something and have a maximum number of pages. So if you had $3 and the maximum number of pages you get is 1. And so for this problem, we just want to know what is the maximum number of pages we can get for $10. And so all that is we just have to access whatever is in this last element, last index of the DP table. And so our answer is 13. And that's reflected right here, output. So let's put this into code. So this is bookshop.py. And so our inputs, we're going to start by getting n and x. So n x is equal to the input of that. And then we're going to get the arrays, or the price data and the page data. So the prices equal to list. And the same thing for pages. And then we can create our DP table. So this is always going to be of a size x plus 1, since we want to account for the 0th index in case you have like $0. And then what we're doing is we're just iterating through each book. So for I in range 0 to n, basically, right? And then so we can get our pages, or our price. We can say that's price I, and then page is equal to pages I. And this is where we're going to construct our DP table. So let's say for j in range, and then we're going to start from the end, so from x to our price, and we want to be inclusive of our price, so p minus 1. We want to make dp of j equal to the maximum of either whatever it is already, or dp of j minus p, which is like the price that we have for the current book, plus the number of pages for that book. So if it makes more sense to add the current book to a price less, then we would do that. And so our answer would just be printing the xth value of our DP table, since that just tells us the maximum number of pages you can get for x. If the problem was asking something else where they gave you an input, you can just input that number. So let's say you want to find the maximum number for 3 pages, then you can do that. For 5 pages, you do that. But here we're just doing x. And so this should work. Let's try this with our test case. So let's see, what did I do wrong here? Oh. And so we can just copy this input and test it, and it gives us 13. Perfect. So now let's submit this and see the results. And so it was accepted. It worked. But yeah, that's the problem. Thanks.